Welcome geometry students to another Kuta worksheet tutorial. Today we're doing the angle addition postulate. Let's go ahead and jump right into this. Well, here we have a number one, all this stuff about KLM, KLB, BLM. What does this all mean? Well, first thing we should probably do is kind of introduce or go over, review. I'm not sure if you've seen this stuff or not yet, so let's just kind of go over it real briefly. All right. Here's the guiding principle behind the angle addition postulate. Okay, let's take a big angle. And actually, I should change the color of these. Let me change the color of this guy. Let's make him purple. Okay, so the big one is going to be purple. Okay, so we have this big purple angle here, and we can see that we can split it up into two smaller angles. We have this blue one, and then we have this green one. Okay, now, essentially what the angle addition postulate says is we can add this green angle plus this blue angle, and it will be the sum of the entire purple angle. Okay, I know that purple's not the same color, but you get the point. So the smaller angle plus the other smaller angle compose, okay, they compose the bigger angle, so you can add them together and it equals the bigger angle. All right. So given that relationship, let me write out the relationship now. So we have the big angle, okay, and you can always put this into an equation, equals, we'll call this the medium angle. I don't think that's the right color. There we go. The medium angle plus the small angle, okay? Or if you want just the two smaller angles added together, give you the big angle. The big point here that I'm trying to make is you can create an equation with this understanding, and from here you can figure out a bunch of different angles. Let me just take this, put it up here as a little reminder. Okay, up here, look at that. Very nice. Okay, let's put this into practice for this one. So we have KLM. Notice how this is the big angle. So let's make it purple. I'm changing the purple. So KLM is the big angle. Okay. We want to find the big angle if we know that KLB, so KLB is this smaller angle, okay, and this medium angle, and we have values for these. And this is how it's going to be most of the time. You're going to have values. So we have this is 26. We have this is, and I know it's degrees. Sorry, let me put degrees. Be consistent here. Degrees. Then we have this guy. This guy is 60. So essentially what we say is, let me write the big picture. I know that I'm really kind of spelling this out a little too much here. But we have KLB plus, oops, that's BLM, sorry. So we have BLM plus KLB, and that's going to be equal to our big angle. That's exactly what we wrote earlier, okay, but I'm just spelling it out in a different way. So we have angle KLM. I forgot the angle. Okay, so that's our big picture. So now we can just put in our values. We have 60 degrees plus 26 degrees. Okay, and that's going to be equal to our big angle KLM, which is asking us to find KLM. And so we figure out that it's 86 degrees, angle KLM. And that's actually measure of K. This M means measure. So anytime we're talking about the measure, like a specific degree, technically we should put the M there. So I'll go ahead and do that. Measure equals 86. Okay, so that's kind of like an easy one. We're also going to have different relationships where there might be subtraction. Let's take number 6, for example. Okay, so here we have the big angle. Boom, boom. Our big angle is 145. Okay, this time we're given the big angle. We know EDC is equal to, angle EDC is equal to, okay, and then we have EDW, this angle here. Let me make it right here. EDW, angle EDW, plus the smaller angle, angle WDC, angle WDC. Okay, get my blue out. So you can see here, it's clearly the addition of those two smaller angles is equal to EDC. But now we have to rearrange it. We just have an equal sign here. Okay, equals, we're given that EDW is 61, so we say this is 61, and then we're trying to find this guy, WDC. If you want, you can call this a variable. You can just leave it as WDC if you want, or you could replace it with a variable and say, hey, let's just call this W. Or let's just call this A or X or whatever you want. Let's just call it X. Okay, so what we do is we're trying to get the variable or WDC by itself, so we subtract 61 from both sides. Okay, what do we get? 145 minus 61, we get 84. So X equals 84 degrees. Okay, that's the same thing as the measure. Let me write this. X, that's the measure of WDC, sorry. So the measure of angle WDC equals 84. Now, do you have to be this specific? If you just write 84 degrees, is it good? In my opinion, it is, but I'm not sure what your geometry teacher is asking. Let's get to the second page here. This one's a little more complicated, but still the same principle applies. We're using the angle addition postulate to formulate equations and then solve for missing angles and variables. So HGF, that looks like the big one. HGF. So that's the big one. HGF. This is going to be equal to the two smaller ones added together. So I'm just keeping it consistent here. We're going to call this guy blue. This guy's blue. This guy green. Okay. So we have FGE or EGF. EGF is 110. EGF. Sorry, I'm just writing it this first, getting maybe a little monotonous, me showing it each time. And then HGE is the blue one. Okay, let's plug in our known values. So we know HGE is 3x plus 11. We know EGF is 110. And we know HGF is 16x plus 4. And as long as we have only one variable, we can get an answer here. We can find a result. So let's go ahead and show how we do that. Well, we can combine like terms first. We have 110 and we have 11, so we can make that 121 plus 3x. I'm changing it to orange, 16x plus 4. First thing we need to do is I like to move the smaller variable to get the variables together first. We have 13x plus 4 equals 121. We're going to subtract 4 from both sides, so we get 13x equals 117. So now I need to do some division. I do 117 divided by 13. Okay, so I divide this by 13, divided by 13, and I get x equals 9. So it's just asking to find x, which is 9 here. Now, if we wanted to find the specific angle measures, if we wanted to find the complete angle measure, we could just plug this in for x here to find HGF, or into x here to find HGE. For example, for HGE, we would do 9 times 3. HGE, this is 9 times 3. 3 times 9. 3 times x, which is 9, plus 11. So that would be equal to 38 degrees. And then we could easily find EGF from there. Maybe let's try to find, let's do one more maybe. Let's go to 18, I suppose. So ABC equals 17x plus 8. This time I'm skipping right ahead. And then we have ABK. ABK we know is 42. So we can say equals 42 and then plus. And then we have KBC, which is 12x minus 4. Be careful with this. I always like to put it in parentheses first, just in case we have minus signs. And to show you we need to be careful if we have subtraction in these types of problems. In this case, there's a positive sign outside the parentheses, so it really doesn't affect anything. Otherwise, if it's a negative sign, we'd have to distribute. But because of that, we can just go ahead and rewrite everything without the parentheses. So 17x plus 8 equals 42 plus 12x minus 4. Combine like terms first. We see we have like term. So we have 38 plus 12x equals 8 plus 17x. I'm going to subtract my smaller variable first to combine like terms, minus 12x. I get 5x plus 8 equals 38. Subtract 8 from both sides. We're trying to isolate the variable here. 5x equals 30. Divide by 5, divide by 5. Division property of equality. X equals 6. Now, you're not done. Okay, this is exactly what I was talking about. We're trying to find measure of ABC. So ABC says, well, look, ABC says it's 17 times x plus 8. So we need to say, okay, measure of angle ABC is equal to 17 times 6 plus 8. So 17 times 6 is 102. So we have 102 plus 8, and that's going to be equal to ABC. Well, that's equal to 110, excuse my disorganization here, is equal to measure of angle ABC. And that's our final answer. So I just wanted to show an example where you have to find the angle. All these other ones, you're using the same principle. I hope you found this helpful, and I look forward to seeing you on West Explains Best next time.